The story of how it all began. In the beginning, there was nothing. No stars, no planets, no light, no time. Just an infinite void. But within that void lay the seed of everything we know today. This is the story of the Big Bang, the event that sparked the universe into existence and set the stage for the cosmos as we know it. It's a tale of unimaginable heat, rapid expansion, and the birth of matter, energy, and life itself. Let's journey back 13.8 billion years to witness how it all began. The singularity, a point of infinite possibility. Our story begins with a singularity, a point of infinite density and temperature. This singularity contained all the matter, energy, space, and time that would eventually become the universe. To call it small would be an understatement. It was smaller than an atom, yet it held the potential for everything. Scientists still don't fully understand what caused this singularity to exist or what came before it. Was it the remnants of a previous universe? A quantum fluctuation in a void? These questions remain unanswered, but what we do know is that this singularity marked the beginning of time itself. At time zero, the universe was a hot, dense, and chaotic place. The laws of physics as we know them didn't apply. Gravity, electromagnetism, and the other fundamental forces were unified into a single, all-encompassing force. Then, in a fraction of a second, something extraordinary happened. The Big Bang. The universe explodes into existence. The Big Bang wasn't an explosion in the traditional sense. It wasn't a bomb going off in space, because space itself didn't exist yet. Instead, it was the rapid expansion of the universe itself. In less than a trillionth of a second, the universe underwent a period of exponential growth called cosmic inflation. During this time, it expanded faster than the speed of light, growing from the size of a subatomic particle to the size of a grapefruit. As the universe expanded, it cooled. The unified force began to split into the four fundamental forces we know today: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force. Energy began to transform into matter, thanks to Einstein's famous equation E equals mc squared. Tiny particles called quarks and electrons started to form, swirling in a hot, dense soup of plasma. The first atoms, building blocks of the universe. For the first few minutes after the Big Bang, the universe was a seething cauldron of particles. Quarks combined to form protons and neutrons, which then fused to create the nuclei of the simplest elements, hydrogen and helium. This process, known as nucleosynthesis, laid the foundation for all the matter in the universe. But the universe was still too hot for atoms to form. Electrons zipped around freely, scattering light and making the universe opaque. It wasn't until about 380,000 years after the Big Bang that the universe cooled enough for electrons to combine with nuclei, forming the first neutral atoms. This moment, called recombination, allowed light to travel freely for the first time. The universe became transparent, and the first light, what we now call the cosmic microwave background, CMB, filled the cosmos. The cosmic dark ages, a universe in waiting. With the formation of neutral atoms, the universe entered a period known as the cosmic dark ages. For millions of years, the universe was a vast, dark expanse of hydrogen and helium gas. There were no stars, no galaxies, and no sources of light. But beneath this darkness, gravity was quietly at work. Tiny fluctuations in the density of matter left over from the early universe began to pull gas together. Over time, these clumps grew larger and denser, forming the seeds of the first stars and galaxies. The universe was about to light up. The first stars, igniting the cosmos. About 200 million years after the Big Bang, the first stars began to form. These stars, known as population 3 stars, were unlike anything we see today. They were massive, hot, and short-lived, composed almost entirely of hydrogen and helium. Inside their cores, nuclear fusion created heavier elements like carbon, oxygen, and nitrogen. When these stars died, they exploded in spectacular supernovae, scattering these elements across the universe. This stardust became the building blocks for new stars, planets, and eventually life itself, galaxies and the large-scale structure of the universe. As more stars formed, they began to cluster together, pulled by gravity into the first galaxies. These galaxies, in turn, formed larger structures like galaxy clusters and superclusters. The universe began to take on the intricate web-like structure we see today, with vast filaments of galaxies separated by enormous voids. Our own galaxy, the Milky Way, formed about 13.6 billion years ago. Within it, a cloud of gas and dust collapsed to form our Sun and the Solar System about 4.6 billion years ago. Earth, along with the other planets, formed from the debris left over from the Sun's formation. The evolution of life, from stardust to sentience. On Earth, the conditions were just right for life to emerge. The heavy elements forged in the hearts of stars combined to form water, organic molecules, and eventually the first single-celled organisms. Over billions of years, life evolved into the incredible diversity we see today. Humans, with our ability to think, reason, and explore, are a product of this cosmic journey. Every atom in our bodies was once part of a star, forged in the fiery furnaces of the early universe. We are, quite literally, made of stardust. The echoes of the Big Bang, evidence all around us. One of the most remarkable aspects of the Big Bang theory is that it's not just a speculative idea, it's supported by a wealth of evidence. The first and most compelling piece of evidence is the cosmic microwave background, CMB radiation. Discovered accidentally in 1965 by Arno Penzias and Robert Wilson, the CMB is the faint afterglow of the Big Bang. It's a snapshot of the universe when it was just 380,000 years old, and it appears as a uniform glow of microwave radiation filling the cosmos. Tiny fluctuations in this radiation reveal the seeds of structure that would later grow into galaxies and galaxy clusters. Another piece of evidence comes from the abundance of light elements in the universe. The Big Bang theory predicts that about 75% of the universe's mass should be hydrogen, 24% helium, and trace amounts of lithium. Observations of the oldest stars and gas clouds match these predictions almost perfectly, confirming the theory's accuracy. Finally, the expansion of the universe itself is direct evidence of the Big Bang. In 1929, astronomer Edwin Hubble observed that galaxies are moving away from us, and the farther away they are, the faster they're receding. This discovery led to the realization that the universe is expanding, and if we rewind time, everything must have started from a single point. The mysteries that remain. Dark matter and dark energy. While the Big Bang theory explains much of what we see in the universe, it also raises new questions. One of the biggest mysteries is the nature of dark matter. Observations of galaxies and galaxy clusters show that they contain far more mass than can be accounted for by visible matter alone. This invisible substance, which doesn't emit or absorb light, makes up about 27% of the universe. Scientists believe it plays a crucial role in holding galaxies together and shaping the large-scale structure of the cosmos, but its true nature remains unknown. Even more mysterious is dark energy, which makes up about 68% of the universe. Discovered in the late 1990s, dark energy is the force driving the accelerated expansion of the universe. Unlike gravity, which pulls things together, dark energy pushes them apart. What it is and how it works are among the biggest questions in modern science. The multiverse. Are we alone? The Big Bang theory has also led to intriguing speculations about the nature of reality itself. Some scientists propose that our universe might be just one of many in a multiverse. According to this idea, the rapid expansion of the early universe could have created bubbles of space-time, each with its own physical laws and constants. In some of these universes, life might be impossible, while in others, it could thrive in ways we can't even imagine. While the multiverse remains a theoretical concept, it challenges us to think beyond the confines of our own universe and consider the possibility of a much larger, more complex reality. The human connection. We are stardust. One of the most profound insights from the Big Bang Theory is our connection to the cosmos. Every atom in our bodies, the carbon in our cells, the oxygen we breathe, the iron in our blood was forged in the hearts of stars. When those stars died, they scattered their elements across the universe, eventually forming new stars, planets, and life. This means that we are not separate from the universe, we are a part of it. The same forces that shaped galaxies and stars also shaped us. As Carl Sagan famously said, we are a way for the cosmos to know itself. The future of the universe. What lies ahead? The story of the Big Bang is not just about the past, it's also about the future. Based on our current understanding, the universe will continue to expand, driven by dark energy. Over time, galaxies will move farther apart, and the universe will grow colder and darker. Stars will burn out, and new ones will stop forming. Eventually, the universe could reach a state of maximum entropy, where no usable energy remains, a scenario known as the heat death of the universe. But this is just one possibility. Some theories suggest that the universe could collapse back in on itself in a big crunch, or that dark energy could evolve in unexpected ways, leading to a different fate. Whatever happens, the universe's story is far from over. The legacy of the Big Bang, a universe of possibility. The Big Bang Theory is more than a scientific explanation. It's a testament to human curiosity and ingenuity. It shows how we can use observation, experimentation, and reason to uncover the deepest secrets of the cosmos. From the first moments of the universe to the formation of galaxies, stars, and life, the Big Bang Theory tells a story of wonder, beauty, and endless possibility. As we continue to explore the universe, we're not just learning about where we came from, we're also discovering where we might go. The Big Bang was the beginning, but it's up to us to write the next chapters of this incredible story. The role of technology. Unveiling the secrets of the cosmos. The story of the Big Bang is not just a tale of cosmic events, it's also a story of human innovation. Our understanding of the universe has been shaped by the tools and technologies we've developed to observe it. From the earliest telescopes to the most advanced space observatories, each leap in technology has brought us closer to unraveling the mysteries of the cosmos. The Hubble Space Telescope, launched in 1990, has been one of the most transformative instruments in this journey. Orbiting above Earth's atmosphere, Hubble has captured stunning images of distant galaxies, nebulae, and star clusters, providing a window into the universe's past. It has helped scientists measure the rate of the universe's expansion, observe the formation of galaxies, and even detect the faint glow of the cosmic microwave background. More recently, the James Webb Space Telescope, JWST, launched in 2021, has taken us even further. With its infrared capabilities, JWST can peer through cosmic dust and observe the earliest galaxies, formed just a few 100 million years after the Big Bang. These observations are helping scientists piece together the story of how the universe evolved from a hot, dense state to the complex web of galaxies we see today. On the ground, experiments like the Large Hadron Collider, LHC, are recreating the conditions of the early universe. By smashing particles together at nearly the speed of light, the LHC allows scientists to study the fundamental forces and particles that shape the cosmos in its first moments. These experiments are not only testing the predictions of the Big Bang Theory, but also exploring new frontiers in physics, such as the nature of dark matter and the possibility of extra dimensions. The philosophical implications. What does it all mean? The Big Bang. Theory isn't just a scientific concept, it's also a source of profound philosophical questions. What does it mean for the universe to have a beginning? Was there something before the Big Bang? And what is the ultimate fate of everything we see around us? For centuries, humans have looked to the stars for answers to these questions. The Big Bang Theory provides a framework for understanding the universe's origins, but it also challenges us to think beyond our everyday experience. It reminds us that the universe is vast, ancient, and full of mysteries we have yet to uncover. Some see the Big Bang as evidence of a creator, a moment of divine intervention that set the universe in motion. Others view it as a natural process governed by the laws of physics and chance. Regardless of one's perspective, the Big Bang invites us to contemplate our place in the cosmos and the nature of existence itself. The cultural impact. The Big Bang in popular imagination. The Big Bang theory has captured the public's imagination in ways that few scientific ideas have. It has inspired books, movies, TV shows, and even a hit sitcom named after it. The concept of a universe born from a single, explosive event resonates with our sense of wonder and curiosity. In popular culture, the Big Bang is often portrayed as a moment of creation, a cosmic explosion that brought everything into being. While this isn't entirely accurate, the Big Bang was more of an expansion than an explosion. It reflects the awe and fascination that the idea inspires. The Big Bang has also become a symbol of human achievement. It represents our ability to explore the unknown, to ask big questions, and to seek answers through science and reason. It's a reminder that despite our smallness in the grand scheme of things, we are capable of understanding the universe on a profound level. The future of cosmology. What's next? As we continue to explore the universe, new questions are emerging. What is dark energy, and why is it causing the universe to expand faster? What is dark matter, and how does it interact with the rest of the universe? Are there other universes beyond our own, and if so, what are they like? These questions are driving the next generation of scientific research. Upcoming missions, like the European Space Agency's Euclid Telescope and NASA's Nancy Grace Roman Space Telescope, aim to map the distribution of dark matter and dark energy with unprecedented precision. Meanwhile, experiments like the Laser Interferometer Space Antenna, LISA, will search for gravitational waves from the early universe, potentially revealing new insights into the Big Bang itself. On the theoretical front, scientists are exploring ideas like string theory, loop quantum gravity, and the holographic principle, which could revolutionize our understanding of space, time, and the fundamental nature of reality. These theories are still in their infancy, but they hold the promise of answering some of the deepest questions in cosmology. A universe of wonder, the legacy of the Big Bang. The Big Bang Theory is more than just a scientific explanation. It's a story of discovery, curiosity, and wonder. It connects us to the universe in a profound way, reminding us that we are part of something much larger than ourselves. From the tiniest particles to the vastest galaxies, everything in the cosmos is linked by a shared origin and a shared history. As we look to the future, the Big Bang reminds us that the universe is full of mysteries waiting to be uncovered. It challenges us to keep exploring, to keep asking questions, and to keep pushing the boundaries of what we know. And it inspires us to see the beauty and complexity of the cosmos, not just as something to be studied, but as something to be cherished. The role of mathematics, the language of the universe. One of the most fascinating aspects of the Big Bang Theory is how deeply rooted it is in mathematics. From the equations that describe the expansion of the universe to the models that predict the formation of galaxies, mathematics is the language that allows us to understand the cosmos. Albert Einstein's theory of general relativity, published in 1915, was a groundbreaking moment in this journey. Einstein's equations described gravity not as a force, but as the curvature of space-time caused by mass and energy. These equations predicted that the universe could be expanding or contracting, an idea that was initially met with skepticism. It wasn't until Edwin Hubble's observations in the 1920s that the expansion of the universe was confirmed, laying the groundwork for the Big Bang Theory. Today, mathematicians and physicists use complex models to simulate the early universe, from the first fractions of a second after the Big Bang to the formation of the first stars and galaxies. These models rely on advanced computational techniques and cutting-edge algorithms, allowing scientists to explore scenarios that would be impossible to observe directly. Mathematics also plays a key role in understanding the fundamental forces and particles that govern the universe. The standard model of particle physics, for example, describes how particles interact through the electromagnetic, weak and strong nuclear forces. While the standard model has been incredibly successful, it doesn't include gravity or explain dark matter and dark energy. Unifying these forces into a single coherent framework, a so-called theory of everything, is one of the biggest challenges in modern physics. The quantum realm, a glimpse into the early universe. To understand the very first moments of the Big Bang, we need to delve into the strange and counterintuitive world of quantum mechanics. At the scales of time and distance that existed just after the Big Bang, the laws of classical physics break down and quantum effects dominate. One of the key ideas in quantum cosmology is that the universe may have undergone a period of rapid expansion driven by a quantum field called the inflation. This theory, known as cosmic inflation, explains several observed features of the universe, such as its uniformity and the distribution of galaxies. However, the exact nature of the inflaton field and how it transitioned into the universe we see today remain open questions. Another intriguing possibility is that the Big Bang was not the absolute beginning, but rather a transition from a previous state. Some theories suggest that our universe could be the result of a collision between two brains in a higher dimensional space, or that it emerged from the collapse of a previous universe in a cyclic model. While these ideas are still speculative, they challenge our understanding of time, space, and the nature of reality itself. The search for primordial gravitational waves. One of the most exciting areas of research in cosmology is the search for primordial gravitational waves, ripples in space-time that were generated during the early moments of the Big Bang. These waves would provide direct evidence of cosmic inflation and offer a glimpse into the universe's first fractions of a second. In 2014, the BICEP-2 collaboration announced the detection of such waves, but the signal turned out to be caused by interstellar dust. Despite this setback, the search continues. Experiments like the Laser Interferometer Gravitational Wave Observatory, LIGO, and the upcoming Laser Interferometer Space Antenna, LISA, are designed to detect gravitational waves with unprecedented sensitivity. If successful, these missions could revolutionize our understanding of the early universe. The multiverse, a universe of possibilities. One of the most mind-bending implications of the Big Bang Theory is the possibility of a multiverse, a vast collection of universes, each with its own physical laws and constants. This idea arises from several areas of physics, including cosmic inflation, string theory, and quantum mechanics. In the context of cosmic inflation, the rapid expansion of the early universe could have created bubbles of space-time, each developing into a separate universe. In string theory, the existence of extra dimensions could allow for multiple universes with different properties. And in quantum mechanics, the many worlds interpretation suggests that every possible outcome of a quantum event creates a new universe. While the multiverse remains a speculative idea, it raises profound questions about the nature of reality. Are we living in a unique universe or just one of countless others? If other universes exist, could they support life, or are they completely alien to anything we can imagine? These questions challenge our understanding of existence and our place in the cosmos. The anthropic principle. Why is the universe just right for life? One of the most puzzling aspects of the universe is how finely tuned it seems to be for the existence of life. The constants of nature, such as the strength of gravity and the mass of the electron, appear to be precisely calibrated to allow the formation of stars, planets, and life. If any of these constants were even slightly different, the universe as we know it would not exist. This observation has led to the formulation of the anthropic principle, which states that the universe must be compatible with the existence of observers like us. In other words, the fact that we are here to observe the universe means that it must have the properties necessary for our existence. Some scientists see the anthropic principle as evidence of a deeper underlying order in the universe. Others argue that it's a selection effect. We can only observe a universe that supports life, so it's not surprising that we find ourselves in one. The multiverse theory offers another explanation. If there are countless universes with different physical constants, it's inevitable that at least one would be suitable for life. As we look to the future, the Big Bang Theory raises questions about the ultimate fate of the universe. Based on our current understanding, the universe will continue to expand, driven by dark energy. Over time, galaxies will move farther apart, and the universe will grow colder and darker. Stars will burn out, and new ones will stop forming. Eventually, the universe could reach a state of maximum entropy, where no usable energy remains, a scenario known as the heat death of the universe. But this is just one possibility. Some theories suggest that dark energy could evolve in unexpected ways, leading to a big rip where the universe tears itself apart, or a big crunch where it collapses back in on itself. Alternatively, the universe could enter a new phase of inflation, creating a new cycle of expansion and contraction. While these scenarios are speculative, they remind us that the universe is dynamic and ever-changing. The story of the Big Bang is not just about the past, it's also about the future and the endless possibilities that lie ahead. The human connection. We are the universe's way of understanding itself. One of the most profound insights from the Big Bang Theory is our connection to the cosmos. Every atom in our bodies, the carbon in our cells, the oxygen we breathe, the iron in our blood, was forged in the hearts of stars. When those stars died, they scattered their elements across the universe, eventually forming new stars, planets, and life. This means that we are not separate from the universe. We are a part of it. The same forces that shaped galaxies and stars also shaped us. As Carl Sagan famously said, "We are a way for the cosmos to know itself." This connection gives us a unique perspective on our place in the universe. We are small, yes, but we are also extraordinary. We are the universe's way of exploring, understanding, and appreciating its own beauty and complexity. The role of philosophy. Asking the big questions. While the Big Bang Theory is grounded in science, it also raises profound philosophical questions that have fascinated thinkers for centuries. What does it mean for the universe to have a beginning? Was there something before the Big Bang? And what is the ultimate nature of reality? Philosophers and scientists alike have grappled with these questions. Some argue that the Big Bang represents the absolute beginning of time and space, while others suggest that it might be part of a larger, cyclical process. The idea of a multiverse, where our universe is just one of many, further complicates these questions, challenging our understanding of existence itself. These philosophical inquiries remind us that science and philosophy are deeply intertwined. While science provides the tools to explore the physical universe, philosophy helps us interpret the meaning and implications of our discoveries. Together, they offer a richer understanding of the cosmos and our place within it. The cultural impact. The Big Bang in art, literature, and media. The Big Bang Theory has not only shaped our scientific understanding of the universe, but has also left a lasting impact on culture. It has inspired artists, writers, and filmmakers to explore themes of creation, existence, and the nature of reality. In literature, the Big Bang has been a source of inspiration for science fiction and speculative fiction. Authors like Isaac Asimov, Arthur C. Clarke, and Carl Sagan have used the concept to explore the origins of the universe and humanity's place within it. Sagan's book Cosmos and the accompanying television series brought the wonders of the universe to a wide audience, sparking a sense of awe and curiosity. In visual art, the Big Bang has been depicted in countless ways, from abstract representations of cosmic explosions to intricate illustrations of the universe's evolution. These works capture the beauty and mystery of the cosmos, inviting viewers to contemplate the vastness of space and time. The Big Bang has also made its way into popular media. The television show The Big Bang Theory, while primarily a sitcom about a group of scientists, has brought concepts like cosmology, particle physics, and astrophysics into mainstream culture. Through humor and relatable characters, the show has made science accessible and entertaining for millions of viewers. the ethical implications, our responsibility to the cosmos. As we learn more about the universe, we are also confronted with ethical questions about our role and responsibilities. The discovery of exoplanets, planets orbiting other stars, has raised the possibility of life beyond Earth. If we find evidence of extraterrestrial life, how should we respond? What are our obligations to other forms of life, and how can we ensure that our exploration of the cosmos is conducted ethically and responsibly? Closer to home, the study of the universe reminds us of the fragility of our own planet. The same forces that shaped the cosmos also shaped Earth, making it a unique and precious haven for life. As we explore the stars, we must also take care of our home, addressing challenges like climate change, pollution, and resource depletion. The Big Bang Theory, in this sense, is not just a story about the past, it's a call to action for the future. It reminds us that we are stewards of a tiny, fragile planet in a vast and ancient universe, and that our choices today will shape the legacy we leave for future generations. The future of cosmology? What's next? The field of cosmology is constantly evolving, with new discoveries and technologies pushing the boundaries of our knowledge. Upcoming missions and experiments promise to shed light on some of the biggest questions in science. The James Webb Space Telescope, JWST, launched in 2021, is already revolutionizing our understanding of the early universe. By observing the first galaxies and stars, JWST is helping scientists piece together the story of cosmic evolution. Future missions, like the European Space Agency's Euclid Telescope and NASA's Nancy Grace Roman Space Telescope, will map the distribution of dark matter and dark energy, providing new insights into the universe's structure and expansion. On the theoretical front, scientists are exploring ideas like string theory, loop quantum gravity, and the holographic principle, which could revolutionize our understanding of space, time, and the fundamental nature of reality. These theories are still in their infancy, but they hold the promise of answering some of the deepest questions in cosmology. The human connection. We are the universe's way of understanding itself. One of the most profound insights from the Big Bang Theory is our connection to the cosmos. Every atom in our bodies, the carbon in our cells, the oxygen we breathe, the iron in our blood, was forged in the hearts of stars. When those stars died, they scattered their elements across the universe, eventually forming new stars, planets, and life. This means that we are not separate from the universe, we are a part of it. The same forces that shaped galaxies and stars also shaped. As Carl Sagan famously said, "We are a way for the cosmos to know itself." This connection gives us a unique perspective on our place in the universe. We are small, yes, but we are also extraordinary. We are the universe's way of exploring, understanding, and appreciating its own beauty and complexity. The legacy of the Big Bang, a universe of wonder. The Big Bang Theory is more than just a scientific explanation, it's a testament to human curiosity and ingenuity. It shows how we can use observation, experimentation, and reason to uncover the deepest secrets of the cosmos. From the first moments of the universe to the formation of galaxies, stars, and life, the Big Bang Theory tells a story of wonder, beauty, and endless possibility. As we continue to explore the universe, we're not just learning about where we came from, we're also discovering where we might go. The Big Bang was the beginning, but it's up to us to write the next chapters of this incredible story. Final reflections. Our cosmic journey. The story of the Big Bang is the story of us. It's a story of how the universe began, how it evolved, and how we came to be. It's a story of stars and galaxies, of matter and energy, of life and consciousness, and it's a story that's still being written, with each new discovery adding another chapter to the cosmic narrative. As we gaze up at the night sky, we're not just looking at distant stars, we're looking at our past, our present, and our future. We're seeing the light of the Big Bang, the glow of ancient galaxies, and the promise of new worlds waiting to be explored. And we're reminded that in the grand tapestry of the universe, we are both insignificant and extraordinary. The Big Bang was the beginning, but it's also a beginning. It's the start of a journey that continues to unfold, a journey of discovery, wonder, and endless possibility. And as we take our place in this cosmic story, we carry with us the curiosity, creativity, and courage that define what it means to be human.